So, welcome to the second and really first non-syllabus uh, video of our quadrivial mathematics series. If you've missed the first video, please consider watching it to see where I'm going with this. But in brief, I'm proposing to put together a 4-year math curriculum for a student who wants to study uh, mathematics in a manner that makes it real and connected to philosophy and theology and gives the student a sense of where all this algebra stuff that they've got to learn fits into the big picture. We do this by looking at math through the fourfold lens of the quadrivium that was founded in uh, ancient times, where we look at math in brief as uh, arithmetic, geometry, music, and astronomy, where arithmetic is the study of number, geometry is the study of number in space, music is the study of number in relationship to other number or number in time, and astronomy is the study of number in space and time. So for geometry, we will get a taste of Euclid's elements and a in-depth uh, Algebra 1 and surveyors trigonometry kind of approach to geometric constructions and analytical geometry, the tools of measuring things if you were going to be a surveyor. That puts everything in context where the algebra fits in as a means rather than just an isolated ends where it can get confused and separated from the target that we want to have. I always want to keep things grounded on where we're going to go with it. Um, Arithmetic is going to give us kind of a high level philosophical overview of exactly what the quadrivium is and what number types are and how patterns evolve and connect to one another. Music is going to give us a sense of how we can move from a pattern that's established to speculating about patterns within that pattern or patterns connecting that pattern or curves connecting the dots within that pattern, and really is the foundation for understanding what algebra gives to us as a language to connect us from the ideas of mathematics to the necessary structures that we'll need for calculus. It's also a beautiful place to get uh, a lot of the foundations of calculus in place. So a student will learn what the goal and notions of calculus are before they need to learn the mechanics of calculus so that again it's grounded. Well, there's no reason for that to be a secret that you have to discover after you've been doing calculus for a year. Uh, and then astronomy really is the calculus. It's a fulfillment of the things that we've built up through the three preceding uh, subjects of the quadrivium and tying it all together. With a nod to its origins in the study of the planets and the harmony of the spheres. So let's dive in. We're going to start with Nicomachus's Arithmetic. This is a book that was written somewhere in the first century AD in Palestine. Um, so in Gaza, unfortunately, there's so much tragedy going on in the world there right now. That Nicomachus was part of that center of civilization right there, where the Greek culture of Palestine in the first century was all along the coast, from Israel down through Egypt, with a mathematical center really at Alexandria. But he's coming from uh, an area on the coast of Gaza, and he wrote 4 books, an introduction to each of the quadrivial subjects. Unfortunately, much of his work is referenced but no longer extant, and we don't have it anymore. And if we had it, we'd have some beautiful things that we might know more about. But I'm going to take his book, Arithmetic, which was uh, for subject matter through all of antiquity and was translated by Boethius in a into Latin in a somewhat abbreviated form in the 500s and became again the core arithmetic textbook of the Middle Ages. And the first thing I want to dispel, and we get this by just reading some of his work, is that our notion of arithmetic now is not what's being discussed here. And this is going to be true with a lot of our words. If we want to say, what is harmony? What is melody? What are the Greek church modes? Uh, all of the language that we inherited from the ancient Greeks um, have been developed over time, and their definitions have altered and changed and improved, and sometimes been just confounded, or as my daughter likes to say, confuzzled. Uh, and Our first job is to reground what exactly do they mean when they're talking arithmetic, because this is not the art of adding and subtracting and multiplying in columns that we learn in second, third, and fourth grade. This is much more a theory of sequences and patterns. So we'll start with some reading here. Uh, some of this, I guess, is probably better for me for the sake of this taking on the form of not a one-off YouTube video, but a series, is to say, hey, you should read this for yourself. So Nicomachus is been around a long time. His books are free. Um, you know, find a print copy somewhere if you want. This one is Britannica's great books, and it's got Euclid and uh, Archimedes and Apollonius and Nicomachus all in there. But I'm going to read some excerpts from this, discuss them a little bit, assign some reading in here, because I think this is a really important grounding point. And this, again, is going to give some illustration of what does it mean to integrate the study of mathematics with the study of history and the study of the wider context of how this stuff fits together. Yes, it will slow us down, but there's an amazing amount of time in high school if it's not wasted. And I'm targeting you, homeschool parents and homeschool students who have that freedom of time. It's not unreasonable for your school day to be much shorter than the student who's locked up in the classroom. So you can take this extra dive and it makes it better. So I'm just going to start at the beginning. The ancients, who under the leadership of Pythagoras first made science systematic, defined philosophy as the love of wisdom. Indeed, the name itself means this. Before Pythagoras, all who had knowledge were called wise indiscriminately. A carpenter, for example, a cobbler, a helmsman, and in a word, anyone who was versed in any art of handicrafts. Pythagoras, however, restricting the title so as to apply to the knowledge and comprehension of reality, calling the knowledge of the truth in this the only wisdom, naturally designated the desire and the pursuit of this knowledge of philosophy as being the desire for wisdom. So that's our first paragraph. And oftentimes I think it's going to be good just to take it a paragraph at a time, skip a few paragraphs, say, hey, read the next one on your own, try and take the same thing out of it that you can. So philosophy, philosophy, love of wisdom. Hagosophia is the Church of the Holy Wisdom before it became a mosque. It's the beautiful church in Constantinople, now Istanbul. So Pythagoras is responsible, according to Nicomachus, who is a Pythagorean. So we'll put that in context. He fully ascribed himself to the Pythagorean philosophy as far as we know. What we know of the Pythagorean philosophy is also a little bit hazy. So, do some research on it if you want. There's some funny things in there. There's some bizarre things in there. How much of it is historically true? Take it with a massive grain of salt. For example, really silly thing, uh, Pythagoras and his cult is how it's referred to mostly. Um, his group of philosophers who followed his philosophy believed that everything in the world could be measured with numbers, and they put numbers up on this pedestal. But they also had some really weird beliefs that, for us, tear that right back down again, which is maybe unfortunate because a lot of their philosophies is quite beautiful and sits very well with a Christian worldview. Um, but they were apparently afraid of legumes. Beans were a thing. And all kinds of, poor taste jokes go around for why they thought that beans were a problem. Um, but don't let that color your sense of what they do have to offer. There's a lot of beautiful things in the Pythagorean philosophy that even if you don't personally ascribe to, it's well worth knowing how they colored the Middle Ages for centuries in terms of the worldview that put God as the master architect, the master draftsman, God the geometer, that says there's this view that God is reaching out to communicate to us through the numbers that he embeds in the universe for us to discover, and that they have theological significance. They're not just random scientific facts. So that's a worldview that he has. And so what Pythagoras is doing here is separating the act of having skills from the act of loving the idea of truth in the abstract. The bigger idea here is that there's a Greek philosophy that puts the things that are immutable and that don't change and that are universals into a special category. You may have heard the term uh, Platonic ideals as things that exist independent of any example. So there is out there in the world, tangible in some sense and yet intangible, but very much real, the idea of dogness. This is an example that I've seen used over and over again. So I'm picking on the classics. So the abstract idea of what a dog is a Platonic ideal. And this retriever or that lab or this wolf or that um, little yappy dog are just examples of dogness. And it isn't any of those dogs that pin down what a dog is. It's a abstraction of all of those particular examples. Same thing has been said about chairs. Like, what is the nature of a chair? It's something you sit on. Is a rock a chair? Is a wooden chair a chair? Is a rocking chair a chair? Is a lazy boy a chair? Is a couch a chair? They're all sort of examples of chairness, but this idea of what a chair is abstractly. I'll borrow a modern term that's come up now that we've got the age of AI. What is a chair in the latent space? Where we move away from any particular word or particular example, but there is some abstract thing that represents a chair. And when we're training a large language model, we're we're figuring out what numbers, what collection of numbers or vectors points at chairness so that you can say this chairness number plus royalty equals throne, or this chairness number plus camping equals a log, or a log, take away, or sitting on a log, take away the logness and add back royalty, converts the log into a throne. And this actually happens mathematically with large language models. So there's like this cool sort of geometry of language that's emerging in our modern IA world. So like, this stuff is very cool, but we've got that in there. So he's looking for this abstract knowledge that's disconnected from particular examples of being a carpenter or a cobbler. Well, they both use geometry, so geometry is the abstract common ground. We'll read another paragraph. So he who studies wisdom, he is more worthy of credence than those who have given other definitions, since he makes clear the sense of the term and the thing defined. This wisdom he defines as the knowledge or the science of truth in real things, conceiving science to be a steadfast and firm apprehension of the underlying substance, the real thing, to be those who continue to be those which continue uniformly and the same in the universe and never depart even briefly from their existence. These real things would be things immaterial, by sharing in the substance of which everything else that exists under the same name and is so called is said to be this particular thing and exist. For bodily, material things are, to be sure, forever involved in continuous flow and change, in imitation of nature and peculiar quality of that eternal matter and substance, which has been from the beginning and which was all changeable and variable throughout. The bodiless thing, however, of which we concede, is connected with and together with matter, such as quantity, quality, configurations, largeness, smallness, equality, relation, actuality, dispositions, places, times, and all those things, in a word, whereby the qualities found in each body are comprehended. All these are of themselves immovable and unchangeable, but accidentally they share in and partake of the affections of the body to which they belong. Now, as it was with such things that wisdom in particular concerned, but accidentally also with things which share in them, that is, bodies. So sorry if I'm not a great reader on that. Again, I would encourage you to read that yourself. But he is, again, just that's the end of chapter one. He is talking to the same point that I did, perhaps in nicer terms, that there is an abstraction of an idea that is separated from the particular attributes of an example. And then he goes a little bit further to say, even those attributes, those accidents, which is the term that was used in philosophy. So again, when you separate that from the modern sense of I got in a car accident, an accident is an attribute or a quality that belongs to something. So this chair could be red. Red is an accident. And you don't need all chairs to be red. It's a quality of that particular one. This chair is large. That chair is small. This chair is well built. That chair is poorly built. Uh, those are all accidents. This dog is hairy and with white curly hair. This dog is tiny with almost no hair. Those are accidents, but the essential dogness underlies all those accidents. So even the accidents is an abstract. The idea of size, the idea of large versus small, is itself something that belongs to wisdom, whereas the color red belongs to worldly circumstances. But the idea of colors, and a spectrum of colors, and a smooth connection between them belongs to wisdom. So we're always interested in pursuing those abstract universals that are immutable and detached from the physical examples, but we still understand them through their physical examples. So this is a sweet spot in here. Plato in Platonic philosophy dives into those abstracts and says those are the real things, and all the things that we see and touch around us, those are shadows. Because they change, because they're corruptible, because they go away, we should not trust them to be the real thing. Modern science makes those the real things and says those abstract ideas, those are just in our heads. So it's a very, very different philosophy to take those. Uh, and I think it is more in tune with a Christian worldview, certainly a classical Christian worldview, to view those abstracts, those words, as things that can become incarnate in an example, but exist whether that example of a red chair exists or not. This gives us a connection as human beings to what does it mean for us to be made in the image of God, to share in some aspect of his mind, because he's conceiving all of these things in the abstract. That's how he makes the world. So we are approaching from a Pythagorean philosophy, from a Platonic philosophy, from this quadrivial worldview, we are approaching God by understanding these abstract notions. And that's the grounded Christian perspective and grounded classically European perspective, separated from the Enlightenment philosophies of why we study science. It's not because somehow the physical world and what we can prove with hypothesis testing is the truth. It's that those particular examples help us frame our understanding in our heads of something that transcends all physical examples and brings us to something bigger, wider, and greater. And so, what Nicomachus is going to go on to, if I have you continue by reading the next couple chapters, is he's going to talk about what is geometry and what is arithmetic. What does it mean to separate out those things which naturally lend themselves to continuous measurement, where we can imagine making it a little bit bigger or a little bit smaller geometry, and those things that require discrete measurement that are they're quantities, where you can have a pile of beads or a field full of cows, and you don't talk in decimals or fractions about your livestock, right? They're discrete. You don't talk to stomp on modern wokeism a little bit here. You don't talk about gender in continuous spectral notions. That belongs to geometry. Male versus female? No, that belongs to arithmetic. That's discrete. It is what it is. It doesn't separate. There's one or the other. And as much as you want to imagine something halfway in between, it's not real. It's the wrong appropriation of abstraction to try and abstract into continuous, which is naturally discrete. And you have to keep an eye out for that. There are careful places, and there are times when you might choose to go down that thought experiment and get some pay dirt. Uh, I'll give one brief example to close out for today, just so we touch on some mathematics um, in the computational sense. So there is a very important idea in mathematics that's used in a lot of probability theory called factorials. We use an exclamation point for the notation of that. And abstractly, that means we take n times the number 1 less than n times the number 1 less than that times the number 1 less than that. And we continue this pattern until we get down to 3 times 2 times 1. Factorials belong to counting numbers. It wouldn't make sense to talk about pi factorial. Doesn't make any sense. But we can talk about 5 factorial. That means 5 times 4 times 3 times 2 times 1. Right? Here is a particular example. This is the idea of something that's mutable, that can go away. This is not what a factorial is. This is an example of what a factorial is. And here is an idea of something that is an abstraction of it, something that goes beyond the particular and describes the notion of a factorial generally. So pi factorial doesn't make any sense. What would that even mean? If we wanted to try and do it, that would be pi. So 3.141592 blah, 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 times 2.141592 blah, 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 times 1.141592. Hopefully you see the problem. I can start with this pattern of subtracting 1, but what happens when I get down to the next step, really? I end up with 0.141592, blah, 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 blah. Well, then what? Do I stop just because I got to a number that's just bigger than 0 and I have to go negative to continue? Do I continue anyways? Do I do something special and different with that? I don't know. My definition of factorial can't cover that. It doesn't work. But I said, well, what if you wanted to imagine something in between? A great example of where we're going to be going with our arithmetic. I can look at the numbers that I do know. 1 factorial is necessarily going to be 1. 2 factorial is necessarily going to be 2. Right, so that's 1, that's 2 times 1, that's 3 times 2 times 1. So here we get the first interest in it. 3 factorial is actually going to be 6. And 4 factorial is going to be 24. And 5 factorial is going to be, so is that 120? No. Yeah, 120. Right? And they grow like that. So we have these dots, and it doesn't make sense to ask what pi factorial is if we think about it in the realm of arithmetic, right? From an arithmetic standpoint, that's a stupid question. If we look at it as we've started to graph it here from a geometric perspective, it kind of suggests there might be a reason to consider kind of connect the dots on this. And if we could connect the dots on this and we could speculate about this number right here, there could be the idea of 2.5 factorial. But I certainly can't calculate it this way. I don't know what to do with my 0.5. I can only go part way down the road and then I go, I don't know, doesn't make any sense. So could I define something that fits there? I don't know, right? It begs the question. But it's a reasonable question to ask when you frame it in geometry, even though it's an unreasonable question to ask when you frame it in arithmetic. And this gives us a beautiful little snapshot of what I mean by this multifaceted approach of we have these different lenses through which we look at a problem with math. And when we frame it from one perspective, we see one set of reality. When we frame it from another, we see a little bit more of reality. They must never contradict one another. They must always sit in synthesis with one another. But it is possible that our factorial idea has a wider definition that exists in geometry that incorporates the factorial idea without compromising or overwriting it or changing it, but augmenting it. And this is one of those places where there could be a right level of thinking of saying, okay, well, this is inherently discrete, but what if that thought experiment works? That wouldn't work for things that are not as numerical as this. Like that's not going to work with gender. The biology of genetics is there is no genome for half male. It just doesn't exist. So you can't get that part in there. It's male or it's female, and that's clearly what it is. And you can't fudge it with the numbers. You can fudge it as a mental idea, and that's as far as you can get. But here, this idea could make sense. And in calculus, this idea does in fact make sense. In calculus, we can go a step further and define a new function. It's called the gamma function. And the gamma function is continuous. We can connect the dots between our points. And in the gamma function, there is something you put in here that turns into something you get out here, even though what you put in here must be integers, must be whole numbers even. And what you put in here can be anything. So there is a gamma of 2.5. I don't know what it is, but it exists. And that's another piece of math that's good to think about is part of the journey towards finding mathematics, again, because it's founded on this idea of appreciating these abstractions. Sometimes, many times, the furthest that mathematicians are able to get on a subject before they exhaust their tool set and they're not sure what we can do next and they have to just let it sit is to claim that something exists. So as we work through this stuff, sometimes that's what we'll do. We'll come to the conclusion that something could exist. We can guesstimate what kind of number it might be, but we have to take as part of our journey that we don't have the skill set yet to address it fully. And we just have to be happy with knowing that it exists or theorizing that it exists and the promise that we'll get around to it later. Thanks for listening.